What do you suggest?
You didn't have any alternative?
Oh, like the paint, the primer paint. Oh yes, sure, of course. But at that time we did not have actual samples of the primer paint. We have that. We have achieved that later on, and it's in my office actually at the university. But at that time, what we had was a description of the primer paint, which is provided. It's in the NIST report, and there's a whole chapter actually on the primer paint, because you can use the primer paint as an indication of the thermal history of the steel beams, and it's very interesting on its own, because when the steel beams were covered by protective paint, and when you heat it up, it starts cracking. It's called mud cracking because it looks like cracked mud, and from the cracks you can actually determine the temperature of the thermal history of the beam. And NIST did not find any steel beams from the core of the towers which has been exposed to beyond 250 degrees centigrade from the primer paint.
And this is in Twin Towers you're talking about?
Yes.
Yeah. Right.
And it's the same number actually from 7. In spite of, most of the steel was actually, hurried away, which is forbidden to remove any evidence from a crime scene. But what the remains that NIST had for observation, none of them, according to the primer paint, had been beyond 250 degrees centigrade. Now this primer paint is described, and its thermal stability is also described, because NIST, or company, it's a private company, did experiments with the beams and heated them up and see what happens up to 800 degrees. And what happened is that this mud cracking when you heat up the primer paint, and around 600 degrees it starts peeling off, and the polymer matrix starts charring, and actually this charring is more or less complete around 800 degrees. Now the point here is that the primer paint is stable. That's one thing. Another thing is the content of the primer paint, and I've actually done these calculations myself, is that the primer paint contains up to 30%, I have to be a little technical here, of zinc chromate, which is the protective agent of the primer paint. And we do not see that. And later on we have achieved actual samples. It's not so easy, but we have got some samples of the primer paint, and they behave completely as expected. I have made experiments with it myself.
When you say the primer paint, you're basing on you've looked at one primer paint from the World Trade Center, is that right?
What do you mean?
I'm asking you how many examples of primer paint from the World Trade Center.
According to the NIST report, there is only one.
Right. I think there's only one used.
And the samples that we have received matches the NIST description. What more can I say?
Your paper, was it published in a leading journal and peer reviewed?
No, it was published in what we call an open journal.
Mm-hmm. And peer reviewed in that?
Oh yeah.
Okay. And what was been the reaction by other scientists? Have you been challenged at all?
Zero. No, challenge? No, not really on the. Some challenge on the methodology. People have asked, why haven't you done this? Why haven't you done that? And this is, you can always say that.
But what's been the reaction of scientists to your conclusions?
No. No. It is beyond doubt the best peer-reviewed paper ever in my career. I would like to know how many times it has been downloaded, how many people have actually read it. Nobody has challenged your conclusions. You can always challenge the details of how the data were made, and this is fair enough. But when it comes down to it now, if you don't believe this, you don't believe that. So what is it? What is the red grey chips? Nobody has come up with a better hypothesis than ours.
I went to speak to Professor Richard Fruhan. He's a professor of metallurgical engineering at the Carnegie Mellon University with 50 years of experience in the field. Associate editor of the leading journal Metallurgical and Materials Transactions Journal, which is peer reviewed. And he says he's never heard of the journal you published in until I mentioned it to him. And he said himself, when he looked and read your report, your paper, he said he would never have published it, your article, in his journal.
So? What's the problem?
Someone who understands it, someone who's a metallurgical expert,
No, yeah.
says that he wouldn't publish it. He says that you made fundamental mistakes in your research.
Or he should publish that if we have made any fundamental mistakes. But maybe I should rather referring to the fact that you're taking in a person who say, I will not publish this. You must understand what has happened to academia in general since 9/11. Because it is a very, very bad career move to bring up 9/11 at all, to talk about it at the lunch table. And this journal we're talking about here, actually my dean was at the External Advisory Board. And his name is Anderson, so he was actually number 1 on the list. This was one of the 4 reasons for publishing in this paper. And
it's not a well-known paper, though, is it? A well-known journal.
No, but it has benefits which I'm ready to explain. And one of them is...
It doesn't go on an abstract service, does it, to other scientists?
I don't know.
No, it doesn't.
Well, so what?
But leading journals would.
Yeah.
They would get a more rigorous peer review.
Yeah, but there are 3 reasons why the leading journal would not accept it for several reasons. One of them is that it is very long. And in a journal which has a printed version, you would never be allowed to put in 33 color pictures. But most importantly to us is that it's an open journal. And you must understand that it is always the scientists who pay for the publication. No matter which kind of journal you're talking about, it's always the scientists paying, because there's the same people reading as there's the same people publishing. So if you pay for the journal by subscription, is basically the same thing as if you pay what we call a page charge. And sometimes you pay both, actually. You both pay for the subscription and you pay for the printing. There is always the scientist paying. But this concept, which is a little new, they tried to break the monopoly of the old journals, which has pushed the subscription rates into what you would say very high levels, and beyond reach of ordinary people. If you want to read a paper from one of the old conventional journals, you have either to be affiliated an institution or go to the library. It's beyond reach for any single individual to subscribe to this because they're simply too expensive. Now, this new concept, which was endorsed by my dean, relies on a different mechanism because it's free. So point 1, everyone can download it, and we wanted this to happen. Point 2, it would never come out, have a printed version because there are too many illustrations. Point 3, we kept the copyrights of all the pictures. We still have the copyrights. If you want to show a picture from this, you would have to ask me because I have the copyrights. But if it had been one of the other journals, you would have to ask the journal. So these are very good reasons for using this one.
Another person I spoke to there at the Carnegie Mellon University, Professor Christopher Pistorius, he says that nobody has bothered to take the time to look at this. It doesn't mean to say it's right, it just means it hasn't been proven wrong. And he said, there are lots of reasons why nobody would take the time. It's frankly irrelevant. It would be fairly easy to rebut, but everybody has got more interesting things to do.
Okay, why are we sitting here?
The reasons they suggested that it was they had problems with your paper is, first of all, they said 20 years ago analysis like yours was done on a few particles, and now they do look at thousands, and within that they would do hundreds of analyses, and that's the sort of work that R.J. Lee or the US Geological Survey would do. They do, and they would do a quantitative analysis as they go. You based on taking 4 samples and then specifically looking out for certain things. They suggest that's not the way science in this way now works.
Bring us the samples. NIST won't give us any.
No, they're saying the way you conducted your own survey of the material, even the samples, take it as read that the samples even are correct and they've been corrected in the right way. They would challenge that, they would suggest that they weren't, they aren't. But however, take it that you've got samples there. The way you've analysed it, they're saying, is wrong. It's an outdated way of looking at it. It's being selective.
Well, do they accept that?
And they don't do as many, and you don't do, it's selective and you don't do as many calculations as others would do.
Do they accept the data?
They look at it and suggest that there are plenty of other good reasons as to what it might be.
Wonderful.
Okay.
Why don't they present them?
Well, they say the most likely source of aluminium in the red chips is paint, specialised cured paint.
Why don't they? So you think that why don't they come up with the suggestion then and publish it? And you think that?
Well, they've done an interview with me and they said it's specialised cured paint.
So why didn't you ask them the reason for putting paint on the World Trade Center, which it actually contradicts what was there, but which was?
I'll give you it. Professor Christopher Pistorius, who's an expert in this type of paint.
You should go and publish that.
Yeah, he said there was this type of paint was in use at the World Trade Center.
He
also suggests that there were lots of different types of paint of this type of primer paint being used, not just one, because there's lots of different types, and so you might have got one sample, but there are lots of others. The type that includes.
May I come in?
Yeah, okay, come in.
Because there are paint in the dust. There are paint samples in the dust, but they don't react.
There's lots of different compositions of paint, is what he's making.
It's contradicting the NIST report. But why don't he publish this? If he claims this, he's in contradiction with the NIST report. His contradiction with our findings. We have published it.
You don't think there were lots of different types of paint being used at
Not according to the NIST report. Tell us about it.
Well, it's listed in the buildings. You could actually go back and look at the buildings. The type of... Okay, sorry, I'll carry on. I mean, I don't think you quite answered this question. Just ask you again, is what they were saying is that rather than taking a few particles and doing analysis on that, they suggested that the modern technique is to do much larger quantitative analysis and do many more samples and many more analysis within those samples.
Yeah.
Weren't you being selective?
What?
Weren't you being selective?
Yeah, we are selecting the red grape chips from the dust, of course.
Trying to find something out rather than being objective.
What should we...
You had a conclusion in mind when you did it.
Yeah. Please, a scientific work and a scientific paper is a set of data and a discussion and the best hypothesis of the day. And that's what it is.
That's what they suggested.
And if they're asking for more, and
Professor Fruhan, let me give you what Professor Fruhan said to me. He said, if you showed me a pile of dust, I could find almost anything in there, but maybe not in a large quantity. You should do more of a quantitative analysis when you look at essentially 1,000 such particles and analyse those with XRD to get a true analysis of what the material is. You could always find something in a pile of dust, and that proves your point. But it would be extremely small, and could be a lot of other explanations for it as well.
Well, why don't you present the other explanations and publish it, please? I mean, you're reading for a piece of paper. It really doesn't count. The only thing which counts in science are published data.
Contrary views don't count.
But he has to stand up. What is missing, basically, or generally, in all this whole discussion about the science thing and the demolition of the towers, is a discussion in a gathering, in a room of peers. And I have tried repeatedly here locally in Denmark, on the technical university, to ask for a symposium or a hearing, whatever you call it, where actually people can discuss this in plenum, in a group where the
But here's someone giving you a specific explanation and challenging what the methods you've used and the conclusions you've reached, and you dismiss it for another reason. Because this time, I like that you dismiss the witness at the Pentagon or the witness at the World Trade Center. This one's dismissed because he hasn't published it.
I shrug my shoulders because he's not saying anything. Basically, maybe we should point to that. He's not saying anything. He's asking for more. So what? I'm asking, does he recognize the data? Does he accept the data? Did you ask him that question? You asked him.
He looked through your paper.
And did he accept the data?
He looked through it and saw that there was an alternative explanation for it.
So, and what was that?
They suggest, the two of them suggest, that it was specialised cured paint. The type of paint that's used, actually specified and used at the moment on the Manhattan Bridge. Did you know that?
Please, why doesn't he publish that?
It's a primer coat used and specified by the New York Department of Transport. Did you know that?
No.
Widely used in New York.
Pardon?
It's widely used in New York. Did you know that?
So you suggest that you have a paint which actually reacts at 430 degrees and produces iron in the process? Is that what you're suggesting?
That if you heat it, then it gives off, eventually it will give off some heat, yes.
And it means that if in a fire, it would be very, the quite opposite of fireproof.
Why do people use things like micaceous iron oxide with polymers and aluminium flake? Why do you think they use that? Does it have a purpose? Why do you think they use those aluminium flakes and micaceous iron oxide?
Excuse me?
Why they use those specialised primer flakes? Do you know why they're being used?
No.
Do you think you don't know why they're being used?
I think what you're suggesting is the application of a paint which is a semi-explosive.
It's being used by the New York Department of Transport at the moment.
Okay. Why do you
think they use it?
Well,
to prepare for future attacks in New York, are you suggesting? Or
prepare for future?
Is that what you're suggesting? I mean,
No,
it's being used at the moment on actual buildings at the moment.